What is descriptive statistics? Descriptive statistics is the branch of statistics that focuses on describing, organizing, and summarizing the data that has already been collected. Its purpose is to present the data in a simple and meaningful way so that the main characteristics of the dataset can be understood easily. Descriptive statistics only works with the data that is available in your study. It does not make predictions, estimate unknown values, or draw conclusions about people, organizations, or situations that were not included in your data collection. Instead, it explains what the collected data shows by using numerical summaries, tables, and graphs. In simple words, descriptive statistics answers one question. What does my collected data tell me? For example, suppose you are conducting research on monthly online shopping expenses of freelance graphic designers. You collect data from 250 freelancers. After collecting the responses, you calculate the average monthly spending, identify the highest and lowest expenses, determine the most common spending range, and create a bar chart showing different spending categories. All of these results are descriptive statistics because they describe only the information collected from those 250 freelancers. They do not tell you anything about every freelance graphic designer in the country. What does descriptive statistics measure? Measures of central tendency. Measures of central tendency show the main value of your data. They answer the question, what value best represents all of my results? The most common measures are the mean, median, and mode. The mean is the average of all the values. It shows the overall average result in your data and gives you a general idea of where most of your results are. The median is the middle value after arranging all the results from the smallest to the largest. It shows the point where half of your results are below it and the other half are above it. The mode is the value that appears most often. It shows the most common result or category in your data. Measures of variability. Measures of variability show how much your results differ from each other. They answer the question, are most of my results almost the same, or are they very different? These measures help you understand whether your data is consistent or whether there are large differences between the results. Common measures include the range, variance, and standard deviation. The range shows the difference between the highest and lowest values. A small range means your results are close together, while a large range means there is a big difference between the smallest and largest result. Variance shows how much all the results differ from the average value. A small variance means most of your results are close to the average, so the responses are fairly similar. A large variance means many results are far from the average, so the responses vary a lot and are less consistent. Standard deviation also shows how much the results differ from the average, but it is easier to understand than variance. A small standard deviation means most of your results are close to the average, showing that the responses are similar. A large standard deviation means many results are far from the average, showing that the responses are more different and spread over a wider range of values. Measures of frequency. Measures of frequency show how often each value or category appears in your data. They answer the question, which results appear the most, and which appear the least. Frequency is the number of times a value or category appears. It shows the actual count of each result in your dataset. Percentage shows how much of the total data each value or category represents. It tells you the share of each result, making it easier to compare different categories, even when the total number of responses is large. What is inferential statistics? Inferential statistics is the branch of statistics that focuses on using data from a sample to make conclusions, estimates, or predictions about a larger population. Unlike descriptive statistics, inferential statistics goes beyond the collected data. It assumes that the sample represents a much larger population and uses probability to estimate what is likely true for that population. In simple words, inferential statistics answers the question, what can my sample tell me about the entire population? Researchers rarely collect data from every member of a population because doing so usually requires too much time, money, and effort. Instead, they collect data from a carefully selected sample and use inferential statistics to draw conclusions about the whole population. Using the same example, suppose the researcher wants to understand the monthly online shopping expenses of all freelance graphic designers in the country. Instead of collecting data from every freelancer, data is collected from 250 freelancers. The researcher then uses inferential statistics to determine whether the findings from those 250 freelancers can be generalized to all freelance graphic designers, estimate the average monthly spending of the entire population, Test whether monthly spending differs based on years of freelancing, monthly income, age, or gender. Examine whether monthly income is related to online shopping expenses, or predict monthly shopping expenses based on monthly income and years of freelancing. These analyses are examples of inferential statistics because they use sample data to make conclusions, test relationships, compare groups, and make predictions about the larger population. What does inferential statistics include? Inferential statistics uses different statistical methods to help researchers make conclusions about a population using data collected from a sample. Confidence interval. A confidence interval gives a range of values where the true population value is likely to fall. For example, a 95% confidence interval of 45 to 52 means the true population value is likely to be between 45 and 52. A narrow interval means the estimate is more precise, while a wide interval means the estimate is less precise. P-value. The p-value tells you how strong the evidence is against the null hypothesis. A small p-value, such as 0.01 or 0.03, means the result is unlikely to have happened by chance, so the finding is statistically significant. A large p-value, such as 0.28 or 0.60, means the result could easily have happened by chance, so the finding is not statistically significant. Correlation analysis. Correlation analysis shows whether two variables change together. It tells you the direction of the relationship and how strong that relationship is. The result is shown by a correlation coefficient that ranges from -1 to 1. A value close to 1 means there is a strong positive relationship. A value close to -1 means there is a strong negative relationship. A value close to 0 means there is little or no relationship between the variables. Regression analysis. Regression analysis shows how one or more independent variables affect a dependent variable. It also helps researchers predict the value of the dependent variable based on the independent variables. The results show which variables have an effect, whether the effect is positive or negative, and how strong the effect is. They also show how well the regression model explains the changes in the dependent variable, often using R superscript 2. For example, an R superscript 2 of 0.75 means the model explains 75% of the variation in the dependent variable. Analysis of variance. Analysis of variance is used to compare the means of 3 or more groups. It helps researchers determine whether the differences between the group means are statistically significant or whether they could have happened by chance. The results usually include an f-value and a p-value. The f-value measures how different the group means are compared with the variation within the groups. The p-value tells you whether those differences are statistically significant. The main difference between descriptive and inferential statistics. Descriptive statistics is used to describe the data that has already been collected. It summarizes the dataset without making any conclusions beyond that data. Inferential statistics is used to make conclusions about a larger population using data collected from a sample. It allows researchers to estimate population characteristics, test research hypotheses, compare groups, examine relationships, and make predictions. Another important difference is that descriptive statistics does not involve uncertainty because it only reports information that already exists in the collected data. Inferential statistics, however, involves probability because it estimates unknown population characteristics based on sample observations. Descriptive statistics can be used with the entire population or with a sample, because it simply summarizes whatever data has been collected. Inferential statistics always starts with sample data, because its purpose is to make conclusions about a larger population. They also differ in the questions they answer. Descriptive statistics answers questions such as, what is the average? What is the most common value? Or, how are the data values distributed? Inferential statistics answers questions such as, is this difference statistically significant? Are these two variables related? Or, can these findings be generalized to the population?